Alternating EMF and current can also be represented in terms of cosine function in place of sine function. Its form will be same, but there will be a phase difference of pi by 2, or there will be some path difference. Path difference is always represented in terms of wavelength, whereas phase difference is always represented in terms of pi. Pi is always expressed in radians, so pi by 2 is 90 degrees. At any instant t, the alternating EMF and current in terms of cosine function will be E is equal to E naught cos omega t. As I have explained you earlier, omega stands for 2 pi n, or omega stands for 2 pi over t. So we can write our functions as shown, that is I is equal to I naught cos omega t, or omega can be replaced by 2 pi by t or 2 pi n. The graph is indicated, the current is indicated by dotted lines, and electromotive force by a strong line, and the times are indicated like t by 4, t by 2, 3t by 4. As the time goes on increasing, we find that there is variation in current and voltage. The graphs representing alternating EMF and current in terms of cosine function are shown as shown, and we'll find the angular speed of the current or voltage in one full cycle of AC is 360 degrees or 2 pi radians. In half cycle, it should be pi radians, that is 180 degrees. The changes of poles occur 2 times in one cycle, that is the direction of current changes 2 times in one cycle. When current is taken above O, it will be positive. When it is taken below O, it will be representing negative. The voltage or current becomes 0 2n times in 1 second, and direction of current changes 2n times in 1 second. N is the frequency of alternating current. The rate of change of alternating voltage or current is maximum when they change their direction, that is positive, negative, or negative to positive. The rate of change of alternating voltage or current is minimum when they are at their peak value. Now we have to discuss the instantaneous value, the peak value, the mean, and the root mean square value. You will notice it nicely that root mean square value and RMS value are two different things. Root mean square value means that is we will take the mean of the values, whereas RMS value is another name given to effective value or the instantaneous value of current and voltage. Different related values of alternating voltage or current in an AC circuit are: one is called the instantaneous value, other is called the mean value, the third one is the peak value, and is the root mean square value, that is RMS value. Root mean square value. What exactly is an instantaneous value? So instantaneous value means that at a specific instant of time. At any system, at any instant, the value of EMF, voltage, or current in AC circuit is called instantaneous value. Instantaneous value of EMF or voltage is represented by E and that of current by I. The instantaneous value depends upon the time and varies simple harmonically in the circuit. That is, it will follow the rules of simple harmonic motion. Instantaneous value is generally represented by I, and instantaneous voltage that is represented by E. The alternative name for the instantaneous values are RMS values, root mean square values, or effective values of current. Now we find that its value may be 0. Now then comes the peak value. The peak value, the positive or negative maximum value of current in one cycle of alternating current, is called the peak value of the current. Peak value of voltage is represented by E naught and that of current by I naught. Now we come to mean value or the average value. The average of instantaneous value of current. Now instantaneous value of current is represented by I. So when we take many times the instantaneous value, we divide it by the number of times the observation is taken. The average of the instantaneous value of current or voltage in one cycle is called its mean value. The mean value of the alternating voltage or current in one full cycle is 0. Now, if we wanted to find the mean value or the average value, its symbolic representation is bar E. And bar E is calculated by taking 1 over t integration of the function e dt from limits 0 to t, and that will found to be 0. Similarly, for mean value or average value of current, we will write 1 over t and we will integrate the function from 0 to t I dt, that is equal to 0. Mean square value. So we take the average values, or we find that the average of the square of instantaneous value in one cycle is called the mean square value. Mean square value of alternating voltage or current in one full cycle is always positive. Mean square value of the voltage is given by function E bar square 1 over t, integrating the limits from 0 to t, E square dt, and that will become E naught square by 2. That is the square of the peak value divided by 2. And same is the explanation for the mean square value of current, and that is found to be I naught square, that is square of the peak value divided by 2. Root means square value. Now RMS value, how is different from the earlier values? Root of the mean of square of EMF or current in an AC circuit for one full cycle is called root mean square value or RMS value. The RMS value of EMF or voltage is represented by ERMS, and for current it is represented by IRMS. ERMS is calculated by function, that is E square bar power half, that is square root, and same is the explanation for IRMS. The square of the instantaneous value of the voltage or current is always positive. Therefore, RMS value is not 0. The RMS value of voltage for one full cycle is given by function, that is ERMS, which is calculated to be E naught over root 2. When we write E naught over root 2, then we multiply and divide by root 2, and the function will become 0.707 of E naught. And the same explanation we can give for IRMS, that is RMS value of current or effective value of current or root mean square value of current. IRMS is also known as instantaneous value of current. So it is written here I power minus 2, but it is not minus 2, it should be I bar, like it is written in electromotive force. In general, RMS value is peak value divided by root 2. If you wanted to have a further integrated value, multiply by root 2 and divide by root 2, and we'll get a number 0.707. The RMS value of the alternating current is also called virtual value or the effective value. In general, when values of voltage or current for alternating circuit are given, those are RMS values. If direct current of strength IRMS is passed through a resistance R, then heat generated per second in resistance will be I square RMS into R. Whenever we write IRMS, we are referring to I naught over root 2. And if direct voltage or value ERMS is applied across the resistance, then the heat generated per second in the resistance will also be E square RMS over R. Therefore, effective values of IRMS and ERMS of AC are equivalent to DC values in reference to their capability of generating heat. IRMS and ERMS are also called the virtual current or the virtual voltage. The virtual current or RMS value of AC is equal to that value of DC which generates the same amount of heat in 1 second across the resistance as given by AC generates. Similarly, the virtual voltage or RMS value of alternating voltage is equal to the direct voltage which generates the same amount of heat in 1 second when applied across resistance R. as the given alternating voltage generates. The amount of heat generated by current in a definite time does not depend upon the direction of flow. The peak to peak value. What exactly we mean by peak to peak value? It is equal to the sum of magnitudes of the positive and negative peak values. So peak to peak value is E naught plus E naught, that is double of E naught. And for E naught we can compute the value root 2 times E RMS. So 2 E naught can be written as 2 root 2 E RMS. If we just calculate 2 root 2, for root 2 we can put 1.414 and we multiply by 2, it will become 2.828 ERMS. Now different values of AC are shown in the following figures. So in both the figures, in one case it is the voltage indicated, that is ERMS is equal to 0.707 of E naught, and that is also we have taken here E square bar is equal to E naught square by 2. Similarly in current, the same explanation is valid.